Hello, Washington Liberty Chemistry students. This is your Unit 2 lesson on counting significant figures. Now, you may or may not have heard the term significant figures before, but it's a very important concept in measurement and in honestly reporting measurements correctly and reporting valid measurements. So why do we use this thing called significant figures? When using a measuring device, you should not cheat and record a measurement better than the instrument is capable of recording. So for example, this scale here weighs out or masses out to the hundredths place, to the hundredths gram. It's a pretty good measuring device. However, you might make a lot of measurements on that device. Maybe you're doing some repeated trials and you're measuring on that device. And you take an average, and your calculator doesn't know any better and gives you an average that goes out to the 10,000ths place or the millionths place. Well, recording that measurement would be dishonest because your average and your measuring device could only go out to the hundredths place. So we have this term, significant figures, that when you're using a measuring device, you don't record a measurement better than the instrument is capable of recording. Now let's see what that means. Let's talk about what a valid measurement is using this POGIL and looking at a couple of different rulers and what a valid measurement is and what an invalid measurement is. So you see you have this ruler and it is only marked 0 and 10. There are no more marks. And you're trying to measure this small little piece of wood. And you put it up against the ruler. Notice what the valid measurements are. A valid measurement that you could report could be 3 centimeters or 2 centimeters. I mean, you're estimating, because you don't have marks. If you, on the other hand, used these would be considered invalid measurements because you have no marks. 2.5, how can you be sure? How can you go all the way out to 3.00 without any marks? All of these things are considered invalid because you don't have any marks. All you can do with this ruler as a valid measurement is estimate. You can see it's not 5. Depending on what you think, you might have put 3 or you might have put 2. Okay, let's look at ruler B. Now, ruler B has been marked by the centimeter. So 0, 1, 2, 3, 4, 5. So you can see we have a mark at 3 centimeters, and we can see with our valid measurement that this is 3 centimeters. We can also estimate the next place. We can see it's 3 point something. Now, opinions are going to differ on that. Is it 3.2, 3.1, 3.3? But we can estimate. A valid measurement has one estimated digit. Notice the invalid measurements. Now you can see this has gone too many digits. We don't have a mark at the tenths, so we can't go out to the hundreds. And this first one, what's wrong with that? Well, our measuring device is better than that. We can see that it's a little bit above 3. So we're not giving our measuring device credit if we just report that as 3 centimeters. Now let's mark it some more and look at ruler C. So you can see ruler C, we've marked the tenths place. So we, with our valid measurements, can pretty much see that this is 3.2. And then we can go out one more. We can estimate one more digit past that. Now you might have to look really closely or get out a magnifying glass to see it's 3.1 or 3.21 or 3.22 or 3.20. But you can estimate out one more place than you have marks. You can see again, these are invalid measurements. This one is not good enough. We can see definitely it's 3.2. Those are both marked. We can go out one more digit. These invalid measurements are going out just one too many. Okay? So let's think about what a valid measurement is in terms of the measuring device and fill in these blanks. So in a valid measurement, you record just one estimated digit. All the measured digits, but just one estimated digit. In a valid measurement, the estimated digit is always the last digit. Everything above that means there was a mark. In a valid measurement, the estimated digit corresponds to 1/10 of the smallest mark. Okay, so let's look at the definition of something called significant digits. You'll see them sometimes called significant digits or significant figures. All right, those two words, digits and figures, are interchangeable. Significant digits or figures in a measurement are all the marked or certain digits that are read directly and the next estimated or uncertain digit. Okay? So even if it is an analytical balance where you don't actually see the marks, the last digit on the measurement on an analytical scale is considered estimated. And you know that that digit sometimes fluctuates, and that's the limit of the scale. So at any measurement you see, the last digit is the uncertain or estimated digit. Okay, so using these rules and using this ruler, and you're measuring this little piece of wood, can you tell me how you would report the length of this wooden splint to the proper number of significant digits? See what you'll get, jot it down, then we'll check it. You should have gotten 7.0 centimeters. Why? Well, the 7 is marked. You can count 1, 2, 3, 4, 5, 6, 7. You know it's 7 for certain. Now, if it's 0.0, it's 0.0. Some of you may have gotten around this by saying 7.1 or 6.9. But the 0.0 is the estimate as well. If you're thinking you're right exactly on that line, you still have to record the 0.0. Otherwise, people are going to think you have a ruler like ruler A that doesn't have marks for each of the centimeters. So you should have put 7.0 centimeters. Okay, so now here's the part that will become obvious as time goes on. But it's very important in measuring, as you're doing calculations and deriving things, that you understand how to count significant figures. All right? So literally looking at a number, a figure, and counting how many of those digits are considered significant in a measurement. Now I'm going to go over the rules first, and then we're going to see some examples, and then you're going to try some practice. So let's just go over the rules. Let's just see where they are. So first of all, if you look at a measurement like 1.33 grams, all non-zeros digits are always considered significant. So you literally just count them. 1.33, 3 significant digits. Any zeros between 2 significant digits are significant. Now here's the thing. What's implied in the first is that non-zero digits are always significant, which means that 0 digits are only sometimes significant. And that's the trick, figuring out whether a 0 is significant or not. So a good way to do this is to give zeros little nicknames. So any 0 between 2 significant digits is counted and considered significant. You can call those zeros between 2 digits sandwich zeros or captive zeros, because you know sandwiches and captives are between things being held. Then we have something called placeholder or leading zeros. These are zeros in front of a decimal. So like 0.0005, none of those zeros are considered significant. They're called placeholder or leading zeros, and they are zeros you do not count. Captive zeros you count, placeholder leader zeros you do not count. Now finally, we have another class of zeros called final or trailing zeros. So the first two are great. Captive, yes. Placeholder, no. Final zeros, it depends. If it's a final 0 at the end of a measurement, it's only significant if the number contains a decimal point. All right? And we'll see some examples of that. And then finally, and this doesn't come out too much, but exact numbers are such as 4 apples or definitions of units like a gram equals 1,000 milligrams have an infinite number of significant figures. Remember, significant figures are telling you about your measuring device, how good it is, how far you can estimate. And if you're a pretty good counter and you have 4 apples in front of you and your measuring device is basically your brain counting, that is exactly 4. That is not an estimated 4. You're counting 1, 2, 3, 4 apples. How many zeros could you put? That's exactly 4. So if it's a counting number, an exact number, it is considered significant. If it's infinitely significant. If it's anything that has to do with a ruler, a scale, a graduated cylinder, that is not exact. You're always going to have an estimate. So here's the key point. Significant digits, which are also called significant figures, are very important in chemistry. Each recorded measurement has a certain number of significant digits, and any digit that is actually measured or estimated will be considered significant. Placeholders, or digits that have not been measured or estimated, are not considered significant and aren't counted. So let's use these rules, have these in front of you as we go through these examples. So if we were to have a scale, goes out to the hundreds place, and we were to record the measurement 1.33 grams. 3 significant figures. We literally count 1, 2, 3. We're following the first rule. They're all non-zeros. They all count. This measurement has 3 significant figures. Let's look at the next measurement. 1.023 liters. 4 significant figures. Now we've got a 0 here. Let's name it. It's a sandwich or a captive 0. It's between two numbers. They are always significant when they're captive. So 1, 2, 3, 4 significant figures. Let's look at the next one. We have 21.00 kilograms. Now, we have a trailing 0 right here. This one's captive, possibly, but we have a trailing 0. We have one at the end, a final 0. There is a decimal in this measurement. That means it is significant, okay? So we have 1, 2, 3, 4 significant figures. Now let me emphasize why we consider it significant. Think of the logic. This is our estimated digit. We have a scale that goes out to the hundreds place. We don't want to put just 21 because our scale goes out to the hundreds place. So that 0 is telling us it's the estimated digit. It's significant. If we just put 21, that would mean we had a scale that was not as good. So we have to put 21.00. We count it as significant. Now let's look at this next one. This is a placeholder or leading 0 in front of a decimal. I want you to think about this. We have this really good scale, actually. It goes out to the thousandths place. However, this is our estimated digit. We're not using these places here. We're only really using the scale, the limit of the scale. So these leading zeros are never, these placeholder leading zeros are never significant. They're just holding the place in the decimal. You could actually get rid of them by writing it in scientific notation. So these are never significant at the front of a decimal. Okay, now let's combine these two rules here. So let's name these. We've got leading placeholder zeros, never significant. Now we have a final 0. This is where we have to check. Is it after a decimal place? Is there a decimal in the number? Yes. Why do we have it there? We have it there to show our estimated digit. So we've got 1, 2, 3 significant zeros. Okay? And actually, I'm sorry, that should say figures. Please correct that on your sheet if you're taking notes. We have 3 significant zeros, but we also have 3 significant figures. We have 1 significant 0. So please do correct that on your note sheet. I'm going to leave it in the video because on the note sheet, many of you have, it says zeros. It should say figures. This 0 is significant. These are not. We have 3 significant figures. Finally, we've got these 2. Now, they look the same, but they're not. Notice this one has 2 and this one has 4. This one has a trailing final 0 and no decimal place. It really is holding a place. And that's because if you look at this, we have to write 2,100 with those 2 zeros. But we really can't tell for certain whether this is estimated, this is estimated, or this is estimated, so we don't count it. Now notice, this one has the decimal place put in. That is telling you that this trailing or final 0 is significant. A trailing or final 0 with a decimal place in the number, like this one, does count. So we have 4 significant figures here. All right, so let's try some practice questions. Take a minute, look at the zeros, decide whether or not they are significant, and then count your digits. Remember, captive zeros, sandwich zeros, always significant. Placeholder, leading zeros, never significant. Final, trailing zeros, only significant if there's a decimal in the number. Okay? All right, so take a look down, put your numbers, count your digits. Let's see if you're right. So 5.0201 grams has 5 significant figures. These are both sandwich zeros, so they count. 0.011 seconds only has 2 significant figures. These zeros are placeholders. They are just holding the place. This is our estimated digit. We really only have 2 numbers that we're using in our measuring device. So that's 2 significant. They do not count. Now this has 2 different kinds of zeros. We have placeholder zeros and we have a final 0. So and a leading placeholder 0. So these do not count, but this one does because there's a decimal in the number. That's our uncertain digit. So we have 1, 2, 3 significant figures. This one here is a final zero with no decimal. It does not count. So we only have one significant figure. And did I trick you on this? 5 apples. Well, my measuring device of counting apples, my brain, which is the measuring device, is better than my scale, is better than my stopwatch. My brain is really, really accurate. So that would have an infinite number of significant figures because it's an exact number. Now, you're going to get some more practice in an exit ticket, and we're going to do lots of examples. So learn from the examples, and this is the end of your notes, though. Thank you.